Good morning. I'm going to try and sell you an idea that you may find a little bit wacky, but which I think has enormous potential for delivering APL applications to a much wider range of clients or use cases than we can at the moment. One of many other ways of making APL available. I'm going to try and explain what it is and why you would want one. But this is a tutorial, really, so I'm going to fairly quickly get into technical details and looking at code. We'll probably spend most of the time actually going through the 22 functions that you need to write or modify on the server side to make this work for your application. Each one of them is maybe half a dozen to a dozen lines. So what is it? Well, this is actually a reincarnation of a project that Björn Christensen and I executed about 15 years ago. There was an SQAPL server then based on a different technology. And we managed to, at Insight Systems back then, we managed to sell it to a few of Dyalog's Unix customers. And we OEM'd the source code to Soliton, who used it as the base for the Times Square relational database that they implemented in APL. But we then got distracted and did other things. But now I think it's a time to bring it back and make it available to a broader audience. I think the infrastructure in the world has changed and it now has enormous potential. So this would allow any APL application to look like a relational database through, and it could be used by any client application supporting any one of these interfaces. And that means, I think, just about any application or development tool on the planet. It's built on third-party software that we use, an open access server from a company called Data Direct, who are one of the big middleware players. And what Björn and I have done is to wrap this open access API in a form which we think is, I hope I can demonstrate to you, is going to be very easy to use for APL developers. And you can use the samples we've got or make minor modifications to them to get your application up and running in a very short amount of time. It'll provide 100% complete standard SQL language support without your having to write a SQL parser or understand, in fact, anything about how to implement SQL. And it supports the full range of operations that you would expect to do on a relational database. So reading and writing, but also defining databases, stored procedures, doing bulk inserts, all the fancy stuff. On the server side, it uses Conga so that you can easily scale it up. You can fire up new APL processes as you need them to support a large number of users. Now, you may be wondering why you would want one of these. I actually think there are a lot of APL applications out there which have data which it makes sense to view in tabular form, and which, if you could expose it through a relational database interface, you'd be able to hook in tools like Crystal Reports or Excel to consume services provided by APL trivially. Now, I think a lot of APL applications do this indirectly today by exporting an extract of data to a relational database and then using tools like the ones we've listed here to do reports. But the advantage of this approach, having APL running dynamically on the back, is, for one thing, that you can be serving up live data. You don't have to guess at some number of terabytes of data that you need to export every night, where the users might actually only query a small amount of that during the day. And because you can handle updates, you can also use this as a way to allow external applications to input data to APL while maintaining all your usual APL integrity checks running on the server side, because you're still just running your application on the server side, receiving these inputs. It may still be a little bit hard to understand what this means, so I think I will quickly demonstrate it. I've been brave and shut everything down This is the open access management console. So this is like what you would expect to have with a relational database. We're going to fire up the instance of our database server. Probably mistyped the password. No. Machines, just I'm going to start the APL database. So now the open access infrastructure is up and running. I then just need to double click on this to start an APL workspace, which fires up Conga and starts listening on a particular port. Once that's up and running, I can open Microsoft Access, for example. Now I've set up an Access database here in advance, where I've linked, you can see I've got 4 tables there: customers, portfolios, prices, and trades. If I double click on customers, I need to log in, and there's my data. Well, it's not very exciting, or is it? This data is actually just the content of a little APL matrix up in the server workspace, which we now have a direct connection to from Access. So if you see, if I change that name and hit enter, Microsoft Access executed an update. Well, actually, first it did a query to check that nobody else had changed the data, and then it executed an SQL update statement, and that changed the value of that entry in the variable. So that in a nutshell is what it does. Isn't that exciting? Well, it has already gone both ways here, right? We fired it up. We looked at. We take the trades table. It's got a few more records in it. Again, that's in the simple example that we provide. Each one of these is just, this one is a matrix with 4 columns. And again, if I go around here making changes to the data, you can see it immediately reflected in, can you see that? No. I can see it, but you can't. It's being cut off.
If you change dialog variable, will it push it back to the 7?
Oh, is that, yeah. If I were to go trade sub 1 semicolon 4 gets 22. Sorry? That would help, wouldn't it? Yeah. I think if we wait for a little bit, Access is going to requery that value. Yeah, see, Access isn't necessarily requerying that. If I were to close this table now, let's see, if I were to try and change this value now, something interesting would happen. Right, you see, Access now redid a query for that key, determined that some other user had obviously edited the database in the meantime. So this is just a feature of Access. It then tells us that it's not going to allow us to commit that change because the value has in the meantime changed to 22. So it shows us that value and we have to re-enter the change. That doesn't have anything to do with how our server is working. That's just Microsoft Access dynamically editing data, checking whether the data has been changed by some other user in the background. Yeah, so this is fully bidirectional. We could go into, let's just do one more demo. Go into Excel and say we want to get some get external data from Microsoft Query from the APL database. We need to log in. It does a data dictionary query, which we've responded to find out which tables are in this database. I'm going to get one called portfolios, which is a bit more interesting because this is actually the same data as in the trades database, except it includes a whole bunch of calculated data, which will, yeah. Okay. So I've changed that data manually in a way that the function, the APL function that's doing the calculations for these calculated columns is failing on. Yeah, probably I've sold so much of this share or something that I don't have anything left or something like that. Let me just... oh, a negative 12 in the... yeah, that's going to be the problem. Tell you what, let me just shut down the APL task. Now I'm in trouble. Obviously, when you have a database server written in APL and it crashes, and you decide to reload the workspace, the ODBC database connection is broken. But, okay. So Excel has recovered. Let's do that again. Get external data. Restarting that workspace reset the content of the database to the defaults, because doesn't have any permanent storage. But I do want to do this example because it illustrates one of the real benefits of serving up data in this way, which is that, okay, so when we just do a default on this, it's doing some tax calculation and it's using the first in, first out method in this case. So it's looking at, we have some holding of Microsoft. When there's negative numbers, it means we're selling. There's only one trade happening each year. It's calculating profits and tax based on, in this case, first in, first out calculation for computing the profit that you're making on each movement. But if we were to retrieve this data again and make a slightly different query, so I'm going to get that same portfolio data out again, but I'm going to filter it on method. I'm going to say I want method equals LIFO. Then the fact that the query contains that filter, method equals LIFO, doesn't mean that a different set of records is being selected, but that's being used as an input parameter to the tax calculation. So when we refresh this value now, we're getting, you can see the same records are coming out, but a different tax calculation has been performed. And this, I think, is the key to why this is really interesting. If you have an APL application, for example, a portfolio management application, where a client could view his portfolio using different interest rate assumptions or different tax calculation methods, set up various parameters on the queries that he's doing, you can still have the client side driving these queries dynamically, making what are essentially function calls to your APL application. But it's all happening in a way that can be driven trivially from a tool like Excel. You can set up crystal reports to do reporting on dynamic data, where if you tried to go the route of exporting a set of data to Oracle or SQL Server and then getting crystal reports to provide the same kind of dynamics, it would be very difficult to set that kind of thing up. Okay, so that's, I mean, does this sound, anybody think they could use this for something? Okay, so it's not completely wacky. Good. Yeah, Tony?
I'm quite sure that I understood when, a couple of minutes ago, when Access wouldn't allow you to change something in APL at auto change.
Well,
change it in APL refresh the database.
Access, there could be many people using Access to, I mean, they've just brought up the contents of this table, right? So what Access does is every time you change a value in Access, it queries that record. It reads it back first. And if the record doesn't have the exact same content that it had when Access read it, it's just telling you that you're in conflict with another user. It's not because I changed it in APL. It could have been another Access user or any other application changing that value.
And if I only change it in APL, it's immediately reflected, or I've got to requery. In other words, is it if you make a change in APL, and
yeah.
you've got some Crystal reports there, is the change pushed, or does Crystal reports have to pull it?
Oh no, I mean tools like Crystal Reports only pull the data when they. But if you had, I mean this is a server. It's responding to queries. It doesn't have any push capabilities. Yeah. But of course you could write an application that was continuously querying the database and pushing data out. Yeah. Okay. So hopefully we've established the why you might want one of these things. No, I should show you. I should show you our QA suite. Obviously, we're very much into test-driven development and all that stuff. Our QA script is, of course, written in APL using the SQAPL client, which is a tool that's been available for 15 years with various APLs, both with Dyalog, APL Plus, Sharp APL. So I'm going to load the SQAPL workspace. How many people here are familiar with SQAPL client? Okay, quite a few. That's good. I'm going to load my QA script. If I can type it all. Get the name right. Picked a really difficult name for this. SQSRVQA. Okay. So I'm going to run the QA 10 times on the data source APL using these credentials. I had too much sleep last night. Just a sec. The name of the function is sqsrv.run. Here we go. Okay, so this tries to be a client-side application program putting the server through its paces. So we log into the database. I then call a stored procedure that I've written called factory reset. This is one of the things that you can't do with your Oracle database in a split second. I call factory reset and all the tables are back to the initial value. It's a nice kind of stored procedure to have. These are the names of the tables. Can everybody read that? Do I need to get the font up? No. So this is the list of tables that I expect to be there. I make a data dictionary call. SQA tables is the call where you ask the database, what tables do you have? And I check that those tables are all in there. This is just the QA. Then, for every single table, I go around in a loop and I retrieve the data dictionary information. So I ask which columns are there and what's the data. So I from cols is the list of columns in the customer. So there's just customer ID, customer name, there's an integer and a varchar. And the data in the table is that. So I loop around for every table that all these 5 tables. I'll quickly go through that 5 times. Then, okay, I check that what I got from the customers table is equal to 1 Jack, 2 Jill. I make some tests on what's in the portfolio. What's in the portfolios table, because now I'm going to go through and do a whole bunch of modifications. I prepare an update statement, update trades, set quantity equals a value where customer ID equals something and code equals something else and year equals something. and then I repeatedly execute that statement, negating the value of the trade. It's not important that you understand exactly what these are doing, but just to show you the kind of QA we're doing. So I loop through every single record, negate the value. Then I negate the value of the data that I have held in the workspace. I do a select star from trades, and I check that I have the same data. I then go through the trades table, deleting one row at a time, and dropping one row from my table, and checking that each time I do a select, I have exactly the table content that I expected. So we're going through maybe 10 times here. Then I close that cursor. I then I have all the copy of the local data in a table. I prepare a statement to insert into trades, custom ID, code, year, quantity, and the values. And I do a bulk insert in ODBC, so that's something that puts all of the data back in a single call. Then I select the data back and check that it's the same thing. And then I do a couple of more complicated statements. Select star from trades where code like M star and cust ID equals 1 or 2. And so this is just to sort of exercise the query engine. And then finally I do a join. Select cust name, year, quantity from customers, comma, trades. Just a very simple join. This is just QA, just to check that everything is working. Okay, and we're done. Now if I just let it run, it's going to run 10 times, and you can see that entire QA script takes roughly a second to run, where we're doing maybe 50, 60 transactions with the database on my laptop, where the laptop's running both the client side and the server side of this QA. So even in this sort of prototype that we're running at the moment, we should be able to do something, 50, 100 transactions per second quite easily, going all the way up and down through this infrastructure. So I think it's certainly fast enough for real use. And if you put this on a multi-core server and multiple APL sessions, you could get pretty high throughput on this thing, if that's what you needed. Okay, so what's going on here? I think we've seen, well, we haven't seen any Java applications or VB C# applications, but we've seen all the other stuff down here, except my demo Crystal Reports license expired. But you've got client applications down here. They could be going through, with a single server that we've built, the Data Direct infrastructure provides JDBC driver, ADO.NET, or ODBC. So you don't need any difference in the logic on the server side. It all gets translated into the same stuff on the top. All of this comes through, these components here are provided by Data Direct, and they're open access server. And then we've written a component in C, which lives on top of that, which is called the interface provider, IP. And then using Conga, that connects to one or more server-side processes. In this prototype that we have at the moment, you can only run one thing on the server side. We need to make sure that we've got some interest from customers before we go through doing the whole scalability story on the server side. But it's already, I think, quite useful. So, yeah.
Is the Data Direct is an out-of-process thing that is communicating with APL, or it kind of wraps the APL and becomes just one thing?
On the client side, well, it's a DLL, so it's probably in process.
Is the DLL running in Dyalog APL space?
On the client side, you're talking to an ODBC driver, which is a DLL. So if you're thinking of using APL as the client.
No, if APL is a server, there's something on the server side also, right? Or is it all client side?
No. On the server side, each one of those yellow boxes at the top there would be a separate APL process.
Right. SQAPL SRV, is that on the server side?
Yes, yeah. This is the network here.
Okay.
So everything from here and up is running on your server. You can also deploy this as a, well, I'm running everything on my laptop here, right? But you could have a network. You could have network here. All these purple things are TCP sockets. So you could have a network layer here, or you could have a network layer above there, because that's
connects from the client side to the OA server, the SQAPL SRV.
And that's the layer that Data Direct provide.
And SQAPL SRV is connecting using a TCP IP socket to APL.
Yeah.
So it goes to this middleware that goes to APL.
Yeah, there are two socket connections. But that stuff is so fast these days. I mean, you can see we can do 100 a second on my laptop. So this stuff is very, very fast. Yeah. So going through that again, on the tech side, you've got your client-side application. It talks to an ODBC driver, for example. That talks to the service provider. And then our layer translates, well, with the help of Data Direct software, we translate the SQL into a parse tree in a form that an APL programmer can hopefully easily deal with. And then we make a bunch of simple calls to the APL application. We're buffering data so that we don't call APL once for every record. We wait until there's a block of stuff. We accept a whole array back from APL, and then spoon feed the client side, which is a C application, and probably calling once for every column in every row. So we take care of all of that buffering. And the SQSRV workspace, which is what we'll spend most of the rest of the time looking at, just contains code which is using a standard Conga-based server, and is just receiving these function calls one by one and needs to deal with them. And this will be available, the Data Direct stuff is available, Windows, Linux, AIX. So you could use it with any Dyalog APL, except probably Windows Mobile. I don't think they have a server component that runs on. Though these days they probably have enough power to do it. And on the client side, you would be able to support anything, really. So just to wrap up the presentation of what it is before we start looking at more code. So this is still a prototype. We're just trying to prove the concept, getting some feedback from people as to whether they'd be interested in it and whether we should incur some fairly significant OEM costs. We need to get these components from Data Direct, get the right to distribute them. So we need 1 or 2 launch customers for this before we can proceed with it. It could be available next year if we get the green light from interested parties. But so it's not quite there yet. This is not something that will just be bundled free with Dyalog APL. We will have to pay licensing fees on to a third party. So we can unfortunately not easily bundle it. Okay.
Do you have any idea what it might cost?
No, I don't. It depends on how many people want to play.
You or play this, depending on how many servers you're running and how many
No, I mean how many customers we would have for this that we could share the cost across. If it's only one customer, it will be expensive. Okay. So let's see. So I mean, basically, the server side is a pretty simple workspace which loads a bunch. This is obviously all, I'm drinking my own Kool-Aid here. It's all script-based, loaded from text files. There's a bunch of scripts. There's really only 2 of them, the ones in green here, that we need to look at, or that you will need to look at to customize this. There's the SQSRV class, which contains these 22 functions that we're going to look at in more detail in a moment. So for example, the first one that comes up here is login. So when when there's a login on the client side, you get a call to this. You have to have a function called login, and it receives the dataset name, data source name, user ID, password, the catalog that they want to connect to, and then some configurable parameters in the driver where you can, they could provide more information about what kind of service they want. And then at the moment we compare the user ID to the password. If they're the same, it's a valid login. Otherwise we reject it. Obviously you'd want to do something else there, but it's just to illustrate the principle. And then there's, at least in the simple sample that we're looking at, there's a namespace called database where you're setting up all the definitions of the databases. So we're, let's see, go down to where we're defining one of the tables. That's probably the easiest thing. So here we're setting up the list of tables, which catalog they're in, the name, etc., various options. We don't have time to go into those, but it's not a lot of stuff going on here. You're just creating some simple arrays in this case that then get translated when the client side asks, well, what tables have you got? This information just gets served up. Okay, so there's 22 functions that might get called while the client is working with your database. We probably won't have time to go through all of them, but hopefully we can at least, I can give you a flavor of how this is working. So these are the ones that have to do with sort of managing the session and the metadata. Login we've just looked at. Transact. Well, if the client side asks you to, it can ask you to do 4 things. There are 4 actions that might be caused. Start a transaction, commit a transaction, roll back, and then number 3, which is the one which I suspect few of you would want to get into. That would be if you have a 2-phase commit. So you get asked to prepare to commit, and then a bit later you're going to be asked to commit because there's a client that's using multiple databases, so it goes around asking them first all to prepare, and then when they've said they're ready, they're all ready, it asks them to commit the transaction. So this one, if you really start accepting complicated updates to your tables, you will have to take this into account. This function is very simple, but of course implementing this kind of functionality, if you need it, could be quite tricky. But I think there's probably most of the applications that would use, you would be doing read-only, you would be serving up data or accepting some very simple updates where perhaps you didn't need transactions at all. You're just accepting a line of input or a stored procedure call, and you don't have to deal with transactions. But if you decide you do want to do transactions, the framework supports it. The data dictionary calls at the moment are extremely simple. They're just returning those variables that we were setting up in the database script. They have some number of columns. These are very simple, yeah. These first 3. Catalogs, there's only 1. Schemas, there are 2. And we have 3 table types. The list of tables itself, here you can see a bit more information about what needs to go into that list. The name of the catalog, the schema, the actual table name, whether it's a table or a view. I'm not sure what those are. Function support is an encoding of whether that table will allow inserts, updates, deletes. So by setting that, you can get the framework to reject updates to a table, for example, without having to validate that yourself. And then a remark. Columns, again, it's pretty simple stuff. It's what you should be accustomed to this if you've been using the SQAPL client. This is the information that you would get if you asked the database what kind of columns there are in a table. So it's catalog owner, table name, column name, data type, type name, and then the length and precision information, whether it's nullable and so on. And the more information you provide there, the more you can get the open access framework to. For example, if you say it's not nullable, you won't get a call if somebody tries to use a null. It'll be rejected by the infrastructure before it gets to you. Statistics, slightly odd name, odd terminology in the relational database world. This is where you give the infrastructure information about what the primary keys, what the keys are in your tables. And you don't have to put anything in here, but there is value in doing so because the infrastructure will use this information in optimizing queries when tables are joined. So it will, and we'll see that in a moment, when you get a query, the information about how to filter the data is split up into, first you get the filters on the key tables, on the key columns, and then you get the other filters. So you can, typically, you would have maybe, you would look at the key fields and then you'd go out and read some data from a component file and get some block of records, and then you'd be filtering the data on the other columns afterwards if you were reading data from a component file. You're not necessarily doing that, of course. Right, so foreign keys, again, you don't need to set these up, but if you do, then when the infrastructure joins tables, it will use that information to reduce the number of queries it makes. Yeah, I haven't explained about the different select modes yet, so it's a bit hard to explain how this affects it. I'll get back to that in a moment. The selection functions, this is important that we get through this. This is probably the most interesting part of understanding what the open access infrastructure, how it makes it easy to implement this, because it provides three modes. You have the option of handling selects in three modes. You can either say, I don't understand any of this SQL stuff. You parse the query, figure out which tables you need data from, and then you just call me once for each table with the filter information that you know can be used to filter what comes out of that particular table. And all of that is handled by the infrastructure. If you do that, then it's very, very easy to integrate it. But of course, if people are doing complex joins, if you decide you have an application where you need to support complex joins, which you may not at all, then you can decide to use what's called pass-through mode, where you execute the entire query, including the joins. And that's what they call pass-through mode. But even there, you have two options. You can use partial pass-through, where you say, well, you're going to join the data and you're going to return at least, or you're going to return all of the records that are required in the result, but possibly more. You haven't done absolutely all of the filtering, because if it's a complicated SQL statement, that might be hard to do. You can look at the statement and say, well, I'm going to need to join this data, but it's a bit too hard to do all of the filtering. Then you can say to the open access framework that it needs to complete the filtering, it needs to do group bys, order bys, because that's all too much work to do. Or finally, you can say, well, I have an SQL parser already. I'm sure there are people who have that. And I'll just eat this complete SQL statement. I'll return exactly what I want you to pass to the client, and the framework doesn't need to do any more. I suspect that people who use this will start with the first one, and then if they start having performance problems on particular types of queries, you can start executing pass-through on some queries, because the way it works, the server allows what's called selective pass-through, which means that you always get the opportunity to do pass-through. You get a pass tree describing the statement. You can look at the statement, and at that point you can decide which one of those three modes you want to be in. So you can say, I know there are certain types of joins which will be horribly expensive if I leave them to the framework. So I'm going to do those, but I'm going to leave everything else to the framework to do. Right, so this is just an example of what one of those trees looks like. I don't know how helpful it is. I've been experimenting with trying to turn the open access framework gives us a nested array, which I've tried to turn into instances of objects in a nested way. And you can sort of see the structure here. It's a select star from customers where customer ID greater than 0 and customer name like J%. So the display form of this object is that, well, the table is customers. The value expression, that is what's being selected from it, consists of two value expressions. There's a value. The value is a column. These are the names of the columns. And by the way, that's number 0 in table 0 and number 1 in table 0. And then there's the filter expression, which is a logical expression where the root expression is and you can see the various, it's not a great display, but you can see the various bits. Here is the customer ID greater than the value 0 and customer name, and this has been translated in this case into the APL function greater than, and then here we call the utility function to execute the like J%. And we also provide a sample which will actually execute that on the data that we have. Yeah, this is a list of the information that you get about the query. I think I'll move on I'll just move on to that. I'll give you 5 seconds to look at it and move on. I mean, you can see all of the information about what might be in the most complicated form of SQL statement, and decide whether you want to deal with it or not. You know, does it have uning? Does it have a having expression, group values, order expressions, and all of that represented in this hierarchical form, which may be a bit daunting, but I think for many APL programmers, dealing with these trees and writing APL code to generate APL execution based on them is not actually a very hard thing. You've done much harder things than that. But again, you don't have to do the pass-through. You can just say, I don't understand this stuff. Call me once for each table. And when you get called once for each table, you can in fact just return all the data. You don't have to do any filtering because the engine is going to perform a final filtering of that data for you, whether you like it or not. This expression here is just in the sample code, just to illustrate the kind of decisions that you might make based on the parse tree. So I'm looking at the parse tree, which is this nested object. I really need a pointer here. Can you see the mouse pointer? Okay, so this says 1 equals row query.tables.items.name. So that's saying, well, it's a query on a single table. And I get hold of I get uppercase of the table name. I then go into my own little data dictionary and get the columns. Then I check whether in the value expression, do we only have value expressions which extract columns? So, and then, let's see. Yeah, and basically, if there is that, then I decide I will execute pass-through because I've written just enough code to handle pass-through in that case. Otherwise, I've set OK to 0, and I'm going to get a call on the simple type of queries. So if you accept that you will do pass-through, then you get asked to, the next call you get is to deliver the first block of data, and you're given a statement handle, a block size, which is currently ignored in the proof of concept. You have to return all of the records in the first block call. And you also get the parse tree that you got when you were making the original decision, but any bind variable values have been inserted into that tree so that you can now execute the statement. And as I mentioned earlier, you have two choices at that point. You can either return the base columns that the engine then needs to do additional filtering and grouping on, or you can say, well, this is the final result, just deliver it exactly as it is to the client. I think I will skip over that code and look at select a bit instead. If you said that you want to handle, you don't want to do pass-through, you just want this call once for each table that's involved, then you'll get a call to a function called select. Now this is a utility function that I called subselect, but it has the same arguments. So you get a statement handle, a table name, you get information about the columns in the table that the client wants, so the column name and number and the data type. Of course, you already have that information, so it's redundant. Oh, no, sorry, these are the results. This is what you need to return as a result. You need to return the column name, number, data type, and the column type, and then each of the columns of output as a vector. So each of the columns is returned as a simple vector. You don't return a matrix. And if there is a query on the table when you're in the simple mode, so if we had this statement here, the same statement that we had before, then instead of getting that deeply nested object, you get some quite simple arrays in, where you say, well, the optimized index, that's the queries on something that you have declared to be a key column, is, well, customer ID greater than is the number 4 and 0 is the value. And then in addition to the optimized index, you get the request for data with filtering, additional filtering. So we want the customer ID, the customer name, these are the data types, and then there's a filter on customer name like J%. So you then just need to write a very simple engine, and we provide an example which handles these filterings. That's quite simple to do in APL. And in this case, the output that you would return, you would say, well, I'm returning, the data is customer ID 1, 2, and customer name Jack and Jill. And that's, I mean, the examples we've been executing do exactly that. And this is the sample code that we provide. So it's calling a little utility function called exec restrictions first on the optimal index, compressing it. I mean, this here is really we don't have time to look at this, but this is all the code that's there. These 2-3 pages are the entire code in the sample for executing queries on simple tables. Okay, here's the exec restrictions. So it's just going around in a loop and doing a bit of anding together of masks and so on. That's really all there is to implement the server, the query side of the server. And updates are not much harder. Well, we're building on the select function that we've just looked at. When the client side wants to do an update, first you get a call to select update. So you're saying update something where blah, 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 blah. So you get that call, you execute the query, and you return, we set a global variable. We return the record set that's been selected, and we internally set a global variable to say, well, what are the indices in the table that were selected? Because when we get the next call, the Open Access Engine may have executed additional filtering, right? It made a simple call to us with the information that could be presented in the simple form, but there may have been a more complex filter going on. So it then calls us back a millisecond later, providing the row index, saying, well, into that data that you decided to return to me, these are the rows that now actually need to be updated. These are the columns, and here's the data, and here are the null values. And in the current implementation, where the data is actually just stored in matrices in that namespace, this is the entire code that performs the update. Obviously, for your application, you'd want to replace this probably by significantly more code, and maybe some locking and so on. Deletion is exactly the same as update, except the statement that we execute at the end is a compression. Inserts are actually very simple. There's only a single call. There's no query first. You just get some data, and we do a catenate on the first dimension. Yeah, the last thing that we have time for is, well, which is also the last thing, fortunately. Stored procedures, these are also very simple. So here's your stored procedure, set tax rate. Set tax rate is a stored procedure which sets the global variable tax rate, which is used in those tax calculations we saw before. And the description of it says, well, there is a stored procedure called set tax rate. It's got one argument. I can't remember what the rest of it is. And the output columns, the columns, one here means it's an input column, so we have an input column called rate, and we have an output column called message, which is the result of this stored procedure. So we get an integer value in, and we have to return something which is a one column, has one column and one row of data in this case. We could have returned a complete record set. It just has to, it has to conform to this this description here. So we don't need to look at that. Okay, so that's all there is to it. Obviously, there's some work to do if you want to use this, but it's I think a lot less work than you would expect to be able to provide incredible connectivity to your application. So think about it. Yeah, Rick.
Was there anything in there to undo an update?
Yes, when you get the call to transact with value 2, which says roll back, then you should have kept a copy of the data somewhere. And no, but I mean, for this database, I think I could do that in a couple of hours. That's trivial. But for your database, it would depend on what kind of commit and rollback. I mean, essentially, you're mapping this to the capabilities that your existing application database has. If it doesn't support commit and rollback, there's no magic involved. This isn't magically going to make your database do commits and rollbacks. Of course, it's not that hard. I guess you could cache the modified data in that workspace, and then it's not hard to do in APL to implement commit and rollback functionality, but, well, depending on your application. Yeah.
One thing you didn't touch on was DDL, data definition language. Can you that create table?
The infrastructure supports it. The example, I don't have any examples of that.
But response would just have a function which would persist the data somewhere and have it available.
Yes, yeah. I mean, you would get, I haven't looked at those functions, but it would be something similar to what you've seen. Create table will be a call. There'll be some information about what the columns should be. It's fairly SQL, ODBC define what's going to be in those calls. It's that information that we've just seen. Yeah.
Theoretically, your APL server could use as its own database some other non-APL.
Indeed, and in fact, I mean, many APL applications use SQL on the back end, and one thing you often have trouble with, I was having a discussion with somebody about that yesterday. You might have a problem with access restrictions, right? It's difficult if you put data into Oracle to define very fine-grained application-specific security using the facilities in Oracle. But if you don't give people access to the Oracle database, they have to go to it through your APL code. Then you can provide exactly the level of filtering that you want. Yeah. Yeah. Extra massaging, filtering, access controls. Exactly. Okay. Well, Oh, Jeff?
That block size stuff, where you hit first block, next block,
Yeah.
that didn't occur on the pass-through code. I think it only occurred on the simple code.
No, I think it was the other way around. It's the pass-through code that has the block size. But we don't implement it.
Is that imposed by the middleware, or is that imposed by the client-side application?
Well, the middleware has the concept. At the moment, Björn's C code is hiding that. The APL programmer gets to return as big an array as he wants, and Björn cuts it all up. But I better stop because there's a potential session change, and Gita and Bernard need some time as well. Yeah. So, thank you.